Hello, grade 8 math. This is 3.8, solving problems with fractions. So when we have a word problem or that sort of thing that we need to solve, or maybe something in life that we're trying to figure out, we need to determine a couple things. First, we need to determine which numbers are relevant. So sometimes, there might be some measurements or some things that have been counted that might actually not be needed to solve a problem. And after that, we need to determine which operation should be done or completed. And there are some ways to kind of help us determine that. If you see words like sum or total or add up to, that means addition. If we see difference or less than, that often means subtraction. If we hear product or we hear times or this of that number, that means multiply. And if we hear the word quotient or shared, that will mean divide. So for this class, I want you to turn to page 148 in your textbook. So turn to page 148 because we're going to look at a bunch of examples in here. And I think that this might be a better way to go through it, is if you turn to page 148. So it says Cassie worked on her science project for 3/4 hours on Tuesday and 5/6 of an hour on Wednesday. She spent Thursday night finishing her math homework. So science was these two, and then Thursday was math. It says, how long did Cassie work on her, Cassie or Casey, I'm not sure, probably Cassie, work on her science project altogether? Okay, let's look at part A just first. Science project altogether. Notice altogether, that implies, that word altogether, it implies or suggests that it should be addition because you're putting it all together. So you take those two numbers, 3/4 of an hour, and you're going to add it to 5/6 of an hour. Keep bumping my camera. Sorry about that, guys. So 3/4 plus 5/6. If we take that and make it a common denominator, remember when you add fractions, we need to have common denominator. So we're going to multiply 4 times 3 to get it to 12, and 6 times 2 to get it to 12. What we did to the bottom, we need to do the top. So 3 becomes 9, 4 becomes 12 by multiplying by 3, and 5 becomes 10 by multiplying by 2, and 6 becomes 12 by multiplying by 2. Now that we have common denominator, we can add our numerators. 9 plus 10 is 19 all over 12. And then we can take 12 of those 19 out to make 1, and we're left with 7/12. So it's 1 and 7/12. These are equivalent fractions. This is just a mixed fraction, which is more useful in being able to refer to, because then you can know that it's 1 hour and then also 7/12 of an hour. So Cassie worked on her science project for 1 and 7/12 of an hour. This note on the side is just how we got to our equivalent fractions. We multiplied by 3 and by 3, by 2 and by 2 to get there. So that was just part A. Part B said, how much longer did Cassie work on the project on Wednesday than on Tuesday? How much longer? Much longer, that implies what? It implies subtraction, right? Longer than. So Wednesday and Tuesday, we had two numbers. Let's look at the solution. So the words longer than, it suggests subtraction. So to find how much longer Casey worked on Wednesday than on Tuesday, you take the amount she worked on Wednesday and you subtract the amount she worked on Tuesday. So how do we do subtraction? Just like addition, we need a common denominator. So we notice here we can multiply this by 2 to get to 12, and this times 2 to get to 12, this times 3 to get to 12, and this times 3 to get to 12. So 5 times 2 is 10, 6 times 2 is 12, 4 times 3 is 12, 3 times 3 is 9. Then we have 10/12 subtract 9/12. 10 subtract 9 is 1, still over 12. Keep your common denominator. So Cassie worked 1/12 of an hour longer on Wednesday than on Tuesday. Longer than was what was in that question. Finally, on page 148, it had part C. It said, altogether, Cassie spent 2 hours on schoolwork over the 3 days. So on Tuesday, Wednesday, and Thursday, the total was 2 hours. So this plus that Thursday would be 2 hours. How long did Cassie spend on her math homework? So we're trying to figure out this one piece that we didn't know on Thursday. So here's the solution. We know that the word altogether, it suggests addition, right? However, the unknown would be with those things being added up. The thing we're trying to figure out, the Thursday, would be in that add up. So, however, to find the time Cassie spent doing math homework, we need to subtract. And I'm actually going to show this solution. I'm going to show this on a different page because I think that my explanation might be a little better than this. But let's look at theirs first, and then we'll do my way. If this makes sense, cool. So for part A, we know that Cassie spent this much time on her science project, right? Altogether, Cassie spent 2 hours on all the schoolwork on 3 days. So if we know that Wednesday and Tuesday plus Wednesday was this, and this is the total, we can take this and subtract that. So I do actually like this solution. I just think that if we didn't have the calculations from A and B, we might want to do it a different way. And so 2 subtract 1 and 7/12. We realize that 2 is 1 and 12/12, right? Because this is 1 and this is 1, so it's still 2. And then we can take our 1, subtract 1, it's gone, and 12 subtract 7 is 5, so 5/12. So Cassie spent 5/12 of an hour on her math homework. So if we didn't know those part A and part B yet, but we were just given the information and tried to solve, we would know that 3/4 of an hour was Tuesday, plus 5/6 of an hour was Wednesday, plus Thursday, I'm going to use a capital T as my variable. That would all equal 2 because it was 2 hours in total. Now, we would need to get our total by itself, right? So we're going to subtract 5/6 from both sides. We're going to subtract 3/4 from both sides. Right? And we'll be left with T equals 2, subtract 5/6, subtract 3/4. And how can we get this so that we can actually subtract? Well, we need common denominators, and all of these can get to 12. So times 3 times 3 times 2 times 2. And this will become, remember this is the same as 2 over 1, so we need to times by 12. We're left with 24 over 12. Subtract 10 over 12, subtract 9 over 12, which that would be 24, subtract 10, subtract 9, all over 12. And it would be 24 subtract 10 is 14. Still have that subtract 9 there, over 12. And 14 subtract 9 is 5, still over 12. So it'd still be that 5/12 of an hour. Notice that it's essentially the same thing. It's just I have the pieces separate because I'm just showing this example so that you can solve a question like part C even if they hadn't yet asked you part A and B. One thing you could do is you could have added these up, 5/6 and 3/4, added those up, and then already had that ready to do exactly what they did in the textbook. There are many different ways that are very similar that you can solve the same problem. Let's look at another example. This is on page 149, so just below the ones that we were just looking at. It says Dakota volunteered at a gift wrapping booth for a local charity. He volunteered for 2 3/4 hours and wrapped 11 gift boxes. His friend Winona volunteered 1 1/3 times as long. 1 1/3 times as long. A, how long did Dakota spend wrapping each gift box? So these 11 gifts, if it took him this long, how much did it take per box? And what assumptions do you make? Flip the page and there is a solution there. It says, we need to think what the problem means. we are given a time for many, so for many of the gift boxes, and we have to find the time for one of those gift boxes, right? We were given a time per 11 gift boxes. We need to figure out the time per one. So this suggests division. When we have the amount of time it takes to do a group of things, it's division. So we take our 2 3/4 divided by 11, and we write the mixed number as an improper fraction. So we need to take our mixed number and switch it to an improper fraction. So we go 2 times 4 is 8 plus 3 is 11. So 2 3/4 is 11 quarters. And we're dividing by 11. Now, remember, 11 is simply 11 over 1. So if we're going to do the multiplying by the reciprocal, this becomes 11 over 4 still, times, switch it to times, and we're going to put a 1 over that. Why? Because we're switching it over. Remember that 11 equals 11 over 1. So its reciprocal is 1 over 11. And then we can cancel out the 11s and we're left with 1 over 4, so 1/4. So our answer here is that Dakota spent 1/4 of an hour wrapping each gift box. They asked what the assumption was, right? What assumption do we make? Well, we're assuming that the entire time he was there volunteering that he was wrapping gift boxes. But as you know, sometimes when you volunteer, there's time for instructions, sometimes there's time for that you're waiting around to do something, sometimes there's conversations you're having, sometimes there's a little break here or there. So we'd be assuming that he was wrapping for the entire time based on our calculation. Part B asked, how many hours did Winona volunteer? So remember, we know that she volunteered for 1 1/3 times as long as Dakota did. So the solution, we realize that the words times as long suggests that we're going to multiply the amount of times longer it was by the amount that the other person did. So Winona volunteered for 1 1/3 times the amount 2 3/4 that Dakota volunteered. So we take that 2 3/4 and we're going to multiply it by 1 1/3. So we know how to do this. We need to write those mixed numbers as improper fractions. So 2 3/4, 4 times 2 is 8 plus 3 is 11/4. And 3 times 1 is 3 plus 1 is 4/3. So this is equal to 11 over 4 times 4 over 3. And we can do this a few different ways, but first way, I notice there's a 4 on top and there's a 4 on bottom. So this is 11 times 4 all over 4 times 3. So we can take our 4's and cancel them out, and we're left with 11 over 3. 11 over 3 is 3 2/3. Why? 3, 6, 9. I counted 3 times to get to 9, and then to get to my 11, there's 2 more of those. So Winona volunteered for 3 2/3 of an hour. So today's assignment is simply just a bunch of these types of word problems and putting what we've learned over this unit and even a little bit last year into practice into problems. I encourage you to ask some questions as you work on it to make sure you're on the right track.